Airboat time. Finding the right balance between vehicle time and time on foot took some work. Driving at full speed propelled players through the world quickly, and in early playtests we felt that players were missing out on exploring and taking in the game's detail. Exploration and world examination are core values of Half-Life, so we didn't want the vehicle to eliminate that. To address this, we added periodic spots where players could get out and explore small pockets of dense detail. Additionally, as the physics system evolved, we were learning new ways to use it. These spots off the airboat let us introduce an element of discovery around physics, like dropping crates into the water or combining barrels to raise a ramp. This gave players a chance to interact with water and physics in different ways.
Floating supplies. In the alpha playtest, the canals were sprinkled with floating supply crates that players could smash with the airboat to collect the supplies inside. The mechanics were somewhat gamey, but helped keep the flow of the gameplay going, allowing the player to resupply on the go. To help make the premise more plausible, we wanted to tell the story of how the floating crates ended up so conveniently placed along the player's path. This scene of the citizens dropping supply crates helped sell that fiction, while also making the canals feel more alive. It also made players feel more heroic and important to be helped by so many supporting characters.
Zombie surprise. There's a little bit of a cheeky jump scare in this sewer pipe. Players wander in here, all focused and curious, and then an underwater zombie pops up, almost always scaring the pants off of playtesters. One fell completely out of their chair, and we mark that moment as a success.
Grenade intro. We conceived of this Combine base as both a training area and a playground for grenades, introducing them here in infinite supply crates to signal that it's safe for players to use grenades freely without fear of running out. Go wild. The Combine encounter here uses extensive markup to direct the soldier AI towards cover and provide good opportunities for players to make use of grenades. At the end of the area, the same infinite grenade technique helps players resolve the turret placement, as a direct assault is a lot more difficult if you don't. A bright red light and a particle trail were added to the grenades, making it significantly easier for players to follow their trajectory, whether they're throwing them or dodging one from a Combine soldier.
Air resistance. One important feature we had to add to our physics engine for Half-Life 2 was air resistance. At the time, physics engines would typically implement a general damping feature for slowing objects down as they moved, but this merely removes energy in a symmetric way. In order to create more believable motion, we decided to simulate air resistance instead. This allowed us to get asymmetric behavior, where the amount the object was slowed by moving through the air was different depending on how much surface area of the object was facing the direction of movement or rotation. This feature was key to making explosions and objects thrown by the gravity gun look believable. Fast-moving and fast-spinning objects are among the most expensive things to simulate in Half-Life 2's physics engine, so air resistance also improves CPU performance in cases like explosions. It is also key to presenting different materials and masses of objects. More dense objects can push aside air more easily, and this is visible. Having this effect in the simulation helps make the difference in density between cardboard boxes and wooden planks more apparent, and really helps make the objects in Half-Life 2's world much more convincing.
Puzzle layers. Because players are often totally unaware of the designer's intent, which we think is a good thing, they tend to respond in all kinds of surprising ways to our puzzles. Even seemingly simple puzzles can see countless failures along the way to success. That was the case with this puzzle to open the canal gates, which required many layers of hints and cues. The sparking wheel communicates that this is where someone would normally open the gate, but some other method is needed. A few crows draw the player's eye towards the solution, in this case, a bundle of girders on a pendulum. As grenades have been thoroughly introduced, we originally wanted players to throw one to break the wooden support structure, but that wasn't obvious enough. We added exploding barrels as a much clearer clue. But even after solving the puzzle, some players didn't realize that the gates were now open, which led them to endlessly explore the base interior looking for another exit. So we had to remind them of their original problem, the broken gate. We added smoke, the alarm klaxon, and a spinning light, and it was then that we finally started seeing reliably good results in playtesting.
Metrocop Strafing. The initial design of the airboat levels aimed to challenge players with tight maneuvers under pressure from Metrocops. The Metrocop Strafing fire pattern was meant to make players slalom around the shots as they sped through, but in a review process, internally known as Overwatch, some playtesters felt frustrated being shot at without a way to retaliate. They wanted the airboat to feel powerful and unstoppable. Based on that feedback, we refocused the levels to emphasize empowerment over challenge, shifting from dodging attacks to fast-paced combat, speed, and busting through barriers.
3D Skybox. We've always needed to render a world that feels larger than our map limitations allow. In Half-Life 1, we used a cube map texture to let players see beyond the playable area. But in Half-Life 2, we wanted that view into the larger world to be dynamic, not just a static texture. Our map size limitation was about half a mile in each dimension, but we realized we could create a much larger outer world if we stored it at a reduced scale. So, we invented what we called the 3D Skybox. The 3D Skybox is a small box hidden within the actual game map containing geometry at 1/16th scale. Inside it, a reference point corresponds to a matching origin in the main map. Then, when we render the space beyond the playable area, we use the geometry from the 3D Skybox, positioned by that reference point and scaled up 16 times. Getting the lighting and fog to blend seamlessly across the transition from the main map to the Skybox presented some sticky challenges, but it worked. The result made the world feel significantly larger and more immersive than it had in Half-Life 1.
357 Intro. The Magnum, unlike the basic handgun with its slower rate of fire, is meant to be fired in a more measured, calculated way, dealing catastrophic damage to your target. Earlier versions of the Magnum had a bit of random dispersion, which we felt fit the heft and the less sensitive trigger pull of a larger pistol. However, this led to anticlimactic moments where players would carefully line up a shot only to miss due to the accuracy penalty. To address this, we made the first bullet perfectly accurate, with each subsequent shot becoming less accurate as you blasted away.
VMPI. During development, we became increasingly frustrated with our slow gameplay iteration speeds, mainly because map compilation, needed to pre-compute lighting and visibility, was taking hours. Computers in 2000 were far slower than today's, and they had only a single CPU core each. Inspired by SETI at Home, a distributed program that used PCs worldwide to analyze radio waves for signs of extraterrestrial life, we built VMPI, which was our own distributed system that spread the map compilation process across many office computers. Today, these kinds of distributed systems run on giant GPU clusters, but at the time we just ran it on all the computers in our office. To deal with how our lighting code was evolving as quickly as our maps were, VMPI also distributed new exe files to everyone's computer too. In retrospect, this was a pretty terrifying security concept, just awfully bad. It's like the stuff of nightmares for IT folks. Because we were sending an arbitrary executable to all of our work PCs, and they would just run it. It was absolute madness. But it worked for us, and it did significantly increase our map iteration speed, and as a result, it ended up being a crucial tool.
Mounted gun. The mounted guns were added here to help train the player on the gun's effectiveness against the attack helicopter for the final battle in the reservoir. This was necessary because up to this point, the helicopter was invulnerable to the player's weapons, and we had to give some indication that it could be harmed with larger weaponry. This was only somewhat effective in playtest due to the amount of pressure the player was under at the moment, which led us to developing the particle effects and sounds that would sell to the players that they were really doing damage.
Helicopter bombing run. This is another example of us creating movement hazards while driving the airboat. The helicopter attempts to stay in front of the player when dropping bombs, and if the player backtracks, it switches to hovering and turns to attacking the player. In one playtest, a bomb just so happened to drop between the pipe seams, creating a pretty cinematic moment. The playtester had a positive reaction, so the team decided to script it so it happened every time. This process has become part of our organic design process. Every so often, a cool thing randomly happens in a playtest, and we find a way to make it happen more reliably.
Smokestack collapse. When making a cinematic action game like the first Half-Life, we'd always wanted to make some big, spectacular destruction sequence, but we were never quite able to do anything like that. Half-Life 2's physics introduced a system for breaking physics small objects, such as crates, into pieces, which provoked the idea of doing something much bigger. We took a leap and tried breaking a smokestack into pieces as it fell. So we experimented with the masses until it felt better, refined the model, and added lots of smoke and audio to sell the effect. And there we had it. We had our big spectacular destruction moment. Ultimately, our physics made the sequence just barely possible in a way that maybe seems quaint by modern standards, but felt really awesome at the time. Because the simulation was unique every time we ran it, we had to take steps to avoid completely blocking the player's path with the big chunks of debris. The success of this sequence whet our appetites for the much higher fidelity cinematic physics destruction effects next seen in Episode 2.
Washing machine puzzle. We created the washing machine physics puzzle late in development, after playtesting indicated that players needed some downtime from the relentless pressure from the helicopter. Pacing contrasts like this can accentuate the high moments by resetting the player's emotional state and warding off exhaustion or even boredom. It was a positive sign that players reacted so strongly to all the work done to make the helicopter truly menacing, but if we didn't manage the stress of it, fatigue set in, which quickly started to feel like monotony rather than excitement. Originally, players quickly drove through this area, but because of the nice sunlight and composition of the canal here, we decided it was a good spot to pause the action and have the player spend some quiet time solving a puzzle. The puzzle itself, which was the first to use masses and pulleys, ended up giving rise to other physics navigation puzzles elsewhere in the game.
Displacements 1. After Half-Life 1 shipped, our level designers and artists wanted a better solution for outdoor environments, so we built the first version of our terrain system. It was based on subdivided quads. To visualize this, imagine a flat square divided into a grid, where each point on the grid can be moved up or down. Level designers could lay out multiple squares and then use a paintbrush tool to shape hills and valleys by adjusting the grid points. For rendering, we used a special blended texture, which combined two different textures. Each grid point specified how much of each texture to use, allowing smooth transitions between surfaces like sand, grass, dirt, and gravel. This type of terrain system wasn't unusual in game engines at the time, and we naively thought it would be enough for our game designers. Displacements 2. Once the initial terrain system was up and running, we expected level designers to use it for outdoor spaces. Instead, they began experimenting, adding detail in unexpected places. They used the subdivided quads on the top of walls to create ruined edges, rounded off street curbs, and even attempted to make pipes. This met with varying success since the terrain system was designed for landscapes, not architectural detail. So we returned to the code mines, transforming the height-based terrain system into a fully 3D displacement system. Now, instead of only moving grid points up and down, designers could move them in any direction. This allowed them to add extra detail to all kinds of surfaces using blended textures to smooth transitions between the displacement quads and the BSP geometry. However, this required additional tech work to ensure consistent lighting between the two renderers, or those edges would have been noticeably mismatched. But with all this done, the level designers seemed satisfied, and we naively thought that this time it really would be enough. Displacements 3. With the general displacement system in hand, level designers didn't stop at adding detail to the world and returned to their original goals of building large-scale outdoor sections. This led to another round of updates to balance performance, ensuring the system could handle both fine detail and larger ground terrain. Texturing had to improve as well, especially to support complex structures like overhanging cliffs that weren't possible with the original height-based system. Designers, never one to rest on their laurels, also started using displacements to create caves and tunnels. While these additions looked great, they required even more technical adjustment. Eventually, we managed to wrangle the competing requirements of all the ways that displacements were being used, and they shipped in large sections of our game world. Looking back, displacements are a clear example of how technology and game design evolved together. It's a chicken and egg problem. We can't foresee all the ways a piece of tech will impact the game, but we also can't build the tech without knowing what it needs to accomplish. So, as is always the case, we have to build something. We start with a solid guess and see where it leads us.
Gestures. Each of our characters had a library of simple animations called gestures, which we could easily layer on top of other body movements. While originally planned as a production savings to allow us to reuse animations throughout the game, we found they actually had more utility than that. Humans often repeat certain movements, and these can be markers of a specific personality. As a result, our gestures library ended up capturing the essence of each character, helping to unify our animation team's understanding of who those characters were. This made it much easier for our animators to share any one character's workload among themselves, which production often required.
Airboat changeup. We heard from the playtesters that they wanted more varied gameplay from the airboat. Up until this point of the game, the player had no real way to fight back against the helicopter and other enemies, so it felt right to introduce a new weapon, and in turn, deliver a pacing change and set the stage for what would come next. In the subsequent areas, we added target practice to acquaint people with their new weapon. Extra physics force on the airgun projectiles meant targets would get sent flying and make it feel way more powerful than anything in the player's loadout. Even then, when it came to playtesting combat against the helicopter, a lot of testers still thought it was invincible, and hadn't noticed our efforts to illustrate that it was taking damage from the Combine-mounted guns earlier. To get over this, we did the most obvious thing. We put the helicopter directly outside the tunnel in which you get the gun and make it extremely clear that you can and should shoot it. And it worked.
Skybox time of day. The skybox and fog color changes incrementally during this chapter. This is meant to visually represent the passage of time as the player journeys through the canals and the chapter. Two fog color values in opposite directions help sell the illusion of the oblique angle of the sun. You can see it getting closer to sunset by this point. This culminates in the helicopter combat arena with the sun setting and Ravenholm visible in the skybox.
A Half-Life game is an ultimately linear experience, but we're always looking for ways to break up the player path and create non-linearity at level scale. This Lambda cache, replaced with a zombie and headcrab ambush, was entirely optional and built only to add some of that non-linearity to this section of travel through the canals.
Donkey Kong Barrel Ramp. This particular area, the drainage ramp, originally started as just an interesting piece of level architecture. But during playtesting, we quickly saw how fun it was to slide the airboat up and around the slope, so we added more elements to enhance that experience. This included Metrocops dropping barrels down toward the player, and a little nod to the classic arcade game, Donkey Kong.
Helicopter Megabomb Origin. The Megabomb helicopter attack was based on a bug where a programmer accidentally removed the bomb drop cooldown, resulting in the chopper dropping hundreds of bombs all at once. It looked so cool that we decided that we had to keep it for the final shipping bombing run attack.
Arena Exit Gate. The wheel mechanism to raise the exit gate was added specifically to force the player to defeat the helicopter before they can move forward. We often refer to elements like this as gating the player, using design elements to keep them from progressing until they've completed a necessary task. Here, it's quite literally a gate.
Helicopter Final Battle. We designed this area as the arena for the final showdown between the player and the Combine attack helicopter. It's the player's chance to finally eliminate the relentless enemy that's been hunting them since fleeing underground after leaving Kleiner's lab. This area went through many iterations to get right. It needed ample space for fast-paced vehicle combat, a smooth movement flow with clear path options, and reliable performance. We also aimed for visual clarity suited to combat, striking but not overly noisy, while ensuring it would serve as a memorable vista once the helicopter is destroyed.